Hi everyone. So we would be talking about the two-pointed approach, intuition. When we talk about techniques to solve problems based on arrays. So let's get started. So first we'll talk about the search techniques that we have. So overall, when we talk about search techniques, we have two kinds of search techniques. First one is linear and the second one is non-linear. So what do we mean by linear? Linear is basically a way of searching an element sequentially in the list, and obviously, as the name suggests, since we are searching every element one by one in the list, the time complexity turns out to be big O of n. And coming to nonlinear approach, so in nonlinear approach, we have a non-sequential way of searching, and the prime example of this is binary search, where we divide the array into halves and then search into the only you know uh, in the half portion of the array, and in every iteration our search space reduces by half. So the time complexity turns out to be big O of log n to the base 2, because we are dividing the array into half. So that's the time complexity that is of binary search. Now let's talk more about linear search before we head on to our two-pointed approach. So linear search, basically what we do is we either start at the either end of the array, which is like either we start from the beginning of the list or from the end of the list, and in a very sequential manner we check the element one by one, and if we match, if our current element is the element we're looking for, if yes, we return the value, or we return from there since we found that, or else we keep on iterating towards the remaining elements one by one. And since this is like checking every element one by one, we do not require any certain kind of ordering mandates in the list, and yeah, which makes it big of and time complexity. Moving on to binary search, so we would be talking about two-pointed approach once we cover binary search topic as well, since that would help us understand that concept better. So yeah, so when we talk about binary search, we have to have the array in a sorted order, either ascending or descending, either way works. Now what we do is we have a mid element every time. We define a lower bound and we define an upper bound. So lower bound is the start index of the current search space, and the upper bound is the end index of the current search space. We find out the middle element between the lower and the upper bound, and then based on that comparison we see if we need to move towards the left of mid or towards the right of mid, or if the element that we're looking for is already present at the mid, then that is where our search stops, or else we keep on our search space reduces by half in every iteration, and because of that we have big O of log n time complexity. Moving on to the comparison between linear search. Actually, we would do a three-way comparison. So linear search, binary search, and two-pointed approach. Now, before we head on to this, let me first tell you that two-pointed approach is basically a combination of both worlds. Like, it is a combination of linear search while also having the capabilities of making decisions on whether to go left or right, which way should we increment or decrement, whatever. So yeah, it's a combination of linear search and binary search. So let's talk about which approach requires sorted data. So linear search and two-pointer approach do not require the data to be sorted. However, binary search is only possible on sorted data sets. Next up, we have approach for these three techniques. So the linear search approach is basically accessing elements in a sequential manner, which is like one by one. And same with two-pointer approach, we check the elements sequentially. We check the element at left pointer, we check the element at right pointer, and then we decrement the pointers or increment the pointers as needed. So then we have binary search, which uses divide and conquer approach, where we divide the array into two halves and then reduce our search space. So when we talk about data volume, we can linear search is best suited for small data sets. The reason being, for very small data set, sorting, we do not need to sort it. So the overhead of sorting actually increases the time complexity in case of a very small data set. So linear search works is efficient on very small data sets, small data sets. But binary search is very efficient on large data sets because our data is sorted and we have literally reduced our search space to log n. So yeah, that turns out to be really efficient on large data sets. When we talk about two-pointer approach, two-pointer approach works well with small and large data sets, both of them, but it is efficient on large data sets. So we've covered this slide. So then we'll talk about algorithm approach of all the three. So linear search, we check for equality, right? We have a look at the current element, we check if it's equal to the target. If no, we move to the next element, and so on. So for binary search, we find the mid between lower bound and upper bound, and then we need to figure out which ways do we need to move. Either we need to move to the left of mid or to the right of mid, or so two-pointer approach basically does greater than and less than comparisons. Next up, we have dimensionality. Linear search works best on 1D and 2D arrays. Binary search only works on 1D array. It does not support 2D. And two-pointer approach supports 1D and 2D arrays. And when we talk about data sets, linear search is fast on small data sets, and binary search and two-pointer approach are faster in terms of large data sets. But in terms of large data sets, linear search turns out to be really slow. So that was it about the intuition for two-pointer approach. I hope this presentation helps you understand the concepts really nicely. And that was it from my side. Thank you.